Hi everybody. We're going to talk about compositions of transformations. Now this video is going to be longer than my normal 3.5 minutes because I am taking a portion of the textbook's manufacturer's version of the PowerPoint, and so this is going to be a little more detailed and a little longer. But I want to convey a few key points. If you want to see the whole presentation with all the examples that they have, I encourage you to go see this PowerPoint, the PowerPoint that I posted on Edmodo under PowerPoint lessons on compositions of transformations, which is module 17.1. But this presentation is going to focus on some key points that I think you need to understand. I hope that before you watch this, you have seen my short presentation on congruence and isometries. In this presentation, we're going to see how multiple transformations, like sequences or compositions of transformations, are used to and how they relate to isometries. We're also going to draw different types of compositions of transformations, and we're going to learn what a glide reflection is. So here are the two terms that I just mentioned. We'll see what those are in a moment. A composition of transformations is simply one transformation followed by another transformation. You could have multiple transformations in a composition of transformations, but in our class we're only going to do two. Okay? So a glide reflection is one example of a composition of transformations. Now let's face it, you can do a reflection and a translation and you don't have to call it a glide reflection. However, in this case, there's something very specific. So read the above very carefully. And then we'll discuss it again in a few moments. For starters, though, it's a translation and a reflection. So let's go look at that. A glide reflection that maps JKL to triangle J prime K prime L prime is the composition of a translation along the vector V followed by a reflection across line L. So you can see the translation and the reflection, and you guys know how to do that. Now, notice how the vector V is parallel to the line L. Okay, that's an important factor, because normally I would just call this a translation followed by a reflection. But the textbook makes a point of saying that this vector is parallel to the line of reflection, and as a result they call the specific composition of transformations a glide reflection. So I just encourage you to keep that in mind, because as we get through our quizzes, I'm probably going to use this term just because it's so important to them in the textbook. Okay, if you have more questions about that, let me know. Now, the other part of this lesson is to understand how transformations, compositions of transformations, affect the shapes and sizes of our shapes, okay, of our pre and post images. So one thing that they point out here is that when you have two transformations, which are both isometries, you can conclude that the image at the end is congruent to the pre-image, and therefore that the composition of two isometries is an isometry. So first of all, they mentioned the transitive property of congruence. So hold on, let's find out what that is. You've probably heard of the transitive property of equality. If A equals B and B equals C, then A equals C. The same holds true for congruence. If A is congruent to B and B is congruent to C, then A is congruent to C. Okay? So what they're saying is that if you have, like in the example of the glide reflection, you have two transformations that don't change the shape, after which each subsequent image is congruent to the previous one, then the final image is going to be congruent to the pre-image. And that's pretty much what they're saying here. Okay? Now, the other thing that that is the focus of this module, is that any translation or rotation is equivalent to a composition of two reflections. And they give two examples of this. They give reflections across parallel lines, and they give reflections across non-parallel lines or intersecting lines. What we're going to see in the next couple of slides is that when you do two reflections of the same object successively across two parallel lines, the end result is the same as if you just did a translation from the original pre-image to the final image. The other example they give is that if you do two reflections of the same object successively across two intersecting lines, your end result is a rotation from the original image from the original pre-image to the image. We're going to see this in detail and explore a couple of these other points here in some exact examples. So here are two parallel lines, L and M, and a shape, ABCD. When you rotate ABCD across, when you reflect it across line L, the image you get looks like that. And when you reflect that second image across M, the image you get is what's represented here by A double prime, B double prime, C double prime, and D double prime. Okay? Now, the distance between these two parallel lines, let's call that D. If you double that distance, you can see that that is the same length as a equivalent translation from ABCD to A double prime, B double prime, C double prime, and D double prime. So this is a rule that if you have two parallel lines and you reflect an object across both of those successively, you will get the equivalent translation from the pre-image to the final image, and the translation vector will be exactly double the distance between the parallel lines. The next example then is of intersecting lines. Now I'm going to tell you from the beginning here that it took me a while to get this animation working and it's not perfect, but I wanted to get this video up, so I'm going to ask you to bear with me on this. Here are two lines that are not parallel and a triangle. If we reflect the triangle across the first line and then reflect it across the second line, we end up with the red image here. That red image is equivalent to a rotation of the pre-image to the final image. Okay? Now, if you see this red angle here between the two intersecting lines, I'm going to try and show you something interesting here. Like I said, this isn't perfect, but what you're going to see is that when you take 2 times the angle, come along here, you get this gray shape here, which actually starts here. That's 1 times the angle, and if you put them next to each other, you got 2 times the angle. And now you move that over here, you can see that the angle of rotation from the first image to the final image is equal to double the measure of the angle between the lines, between the original lines. So I get that that can be a little confusing. If you want, you can rewind this and watch it again. I simply wanted to show you a little more detail on the theorems that they were showing in the larger presentation. So in short, this module is about how the composition of 2 isometries is still an isometry, so that your end result is congruent to your original pre-image. And if you actually jump down to the last one, any translation or rotation is equivalent to a composition of 2 reflections. A translation can be the composition of 2 reflections across parallel lines. A rotation can be the composition of reflections across intersecting lines. That's all there is to this. Please work on the homework. Hopefully this will help you with that, and we'll see you in the next video.